This is section 13.1, and it's called factoring using the GCF. GCF is an acronym that stands for greatest common factor. And just like before, I'll give you definitions, I'll explain it, and then we'll do the same thing with Word. So one thing we could do is make a prime factorization tree. And then we could also select the largest factor in common or the smallest power. And I'll explain what this means as we go through our examples. So first few examples, let's just prime the GCF. And we're looking for the greatest common factor between 12, 20, and 28. But really, what's the largest number that we could divide into 12, 20, and 28? And I know 2 goes into everything. Or anything bigger than 2? 4? Anything bigger than 4? Well, right. The way we could have found that is by factoring these. So 12 is the same as just 2 times 6. 6 is the same as 2 times 3. When we make a prime factorization tree, the prime numbers start at 2, then you have 3, 5, 7. Those are all prime numbers, right? So 12 is the same thing as just 2 times 2 times 3. Twenty is the same thing as 2 times 10, which is 2 and 5, or 2 squared times 5. 28 is the same thing as 2 and 14, or 2 times 7. So 2 times 2 times 7. And if we're looking for the largest number in common, this has a 2 squared, so does this, so does this. If one of them was a 2 to the third, you would pick the smaller one. So between 2 squared and 2 to the third, you go with 2 squared. The GCF here would just be 2 squared over 4. It seems like you guys could figure that out without making a tree. What if we had x to the second, x to the fifth, and x to the fourth? We're looking for the smallest power, right? X to the second. Yeah. So this is really the same thing as x times itself twice. This is x times itself 5 times. This is x times itself 4 times. So what's the most that they all have in common? You take 2 out of this. That's the most you could take out there. You could take 2 out here, and you could take 2 out here. That's why it's x to the 7. If you take out x, that would be like taking 2 out of the last one. You could go even bigger than that, right? What if we had x to the third, y to the fourth, x to the second, y to the sixth, and then x to the fourth, y to the third? So first thing, let's look at the x's. The smallest power between 3, 2, and 4 would be 6 to the second. And between 4, 6, and 3 would be y to the third. Well, let's try 18x to the third and 40x to the fifth. So think about what's the biggest number you can divide into 18 and 40. Well, 18 is the same thing as 2 and 9 minus 3 and 3. So this is 3 squared times 2. 40 is the same thing as 2 and 20, 2 and 10, 2 and 5. So this would be 2 to the third times 5. So can't use 5 because that's not uncommon. Can't use 3s because not each term has a 3. This one has a 2. The 2 to the third has 3. So we go with the smallest power. It would just be 2x to the third. So now that we know what the GCF is, there's a different type of problem where we factor out the GCF. Let's say we have 14x squared minus 20x to the third. First thing we do is we figure out what is the GCF. So the GCF between 14 and 20, the biggest number that goes into 14 and 20, I think is 2, right? And then x to the second. So our GCF is 2x to the second. So the way this is going to work is we're going to divide each term by 2x to the second. Write the GCF on the outside, and then write what's left over on the inside. 14 divided by 2 is 7 minus 10x. That would be what GCF factoring is like. Figure out what the GCF is, and then you divide it term by it. Really, the word factor means write as something times something else. That's what factor means. If you're going to factor 10, you would say 10 is 2 times 5. Well, what if we had 3 times x minus 5 plus y times x minus 5? We'll look at each term, this one and this one. Both terms have an x minus 5 in common. So what we could do is divide both of these by x minus 5. And then write the GCF. And then write what's left over. So the GCF would be x minus 5. And then what's left over is the 3 plus 1. Another one, negative 4x to the fifth, y to the third, plus 20x, y squared. We gotta see if we can figure out what the GCF for this would be. Alright, so one thing about GCF is if the first term is negative, the GCF also has to be negative. Right, so it looks like we definitely have -4 x to the first, y to the second, that would be our GCF here. Because the first term is negative, the GCF is negative. 4 is the biggest number. You can divide into 4 and 20. What we're going to do is divide each of these by -4xy squared. And then we're going to write our GCF, and then what's left over. Would be -4xy squared. And then if you divide it, you just get 1x to the 4th y minus 5, and that's it. And then I want to finish up this section by talking about what's called factor by grouping. When we do factor by grouping, really what we're doing is just GCF factoring twice. So if we had 2x to the third minus 4x squared minus x plus 2, factoring by grouping just tells us to cut down the middle and use GCF factoring twice. Show you what I mean here. So we'll cut it down the middle, just like I told you. And this is really two separate problems. So the GCF between the first half, 2 and 4, would be 2. And then x to the second. So if we're going to factor that, we just get the GCF and then what's left over. And then the second group, the GCF between -x and 2, probably just going to be -1. I remember the GCF has to be negative, leading terms negative. And then we just get x minus 2. We know we did this correctly if these are the same. And they are. So the way that we finish a problem like this is you write the new GCF. Then you write what's left over. That makes sense, guys? Really, there's 3 GCF. You had a GCF from the first half, GCF from the second half, and now the GCF from this. Well, we'll do a couple more of these so you get the hang of it. What about x squared plus 2x minus xy minus 2y? Just like before, we'll cut it down the middle. Take out the GCF of the first half, second half, and then all together. First GCF would just be x. We get x plus 2. Second one, we know it has to be negative because the leading term is negative. And it looks like we'll have a y, so we'll take out a negative y. And if we did it correctly, we'll just get x plus 2. Then we could take out the new GCF of x plus 2, and we're left with x minus 1. We'll do one more of these. What if we had 2x to the third y minus x squared y plus 5xy squared plus xy to the third? Just like before, we'll cut it down the middle. And we'll take out the GCF for each half. All right, so let's go ahead and cut it down the middle. Looks like both terms have an x to the third, x to the second. The smallest power would just be x squared. And then both terms have a y. So factoring that out, we're left with just 2x minus 1. And in the second group, it's like we could take out an x and a y squared. And we're just left with 5 plus y. But these aren't the same. So it's not factorable. So let's just say can't factor. We'll just leave it like that.